Thank you very much, Wyld. Appreciate the introduction, and I appreciate the opportunity that LoRaWAN Live is offering us to talk to you about how we can apply LoRaWAN in the context of smart farming. The way we're going to do this is, first, I wanted to go to a quick problem statement, just numbers. But clearly, within the context of IoT, there is a huge opportunity before us. At the same time, in the context of LoRaWAN, we have a tremendous opportunity for growth. Now, the question is, how do we pair the opportunity in smart agriculture with the opportunities that LoRaWAN provides? And I think the interesting thing about our panel is that each one of us has an interest and experience in applying LoRaWAN into solving problems in the context of smart agriculture and smart farming. So I wanted to start by letting my colleagues introduce themselves, and then after that we will go into specific short presentations, sharing a little bit of our experiences, and then we will transition into a discussion session. So I'm going to start from the far right. Anas, if you don't mind, introducing yourself.
Hello, everybody. My name is Anas Wali. I'm from 3S Tunisia. We are a system integrator, and we are deploying a nationwide LoRaWAN IoT network in Tunisia. We work mainly on use cases, and you will see through the presentation how our approach is in order to address the market in emerging countries.
Please, Chris.
Perfect. Yeah. Good afternoon, everyone. So Chris Batterby from WIKA Instruments. We are perhaps one of the largest solution providers in the world, but over the last 4 or 5 years, we've really been focused on delivering end-to-end solutions, particularly in the dairy industry, but largely focused on delivering durable value for farmers specifically.
Thank you. Eric?
Yep. Hi, my name's Eric Hewitson. I'm from Wyld Networks, and we focus on sensor-to-satellite connectivity and do have a number of projects in agriculture, particularly around soil moisture sensing and other things that we will discuss.
Thank you so much. So, first section is mine, and I wanted to give you a little bit of background on myself. My name is Ciprian Popovic. I work for East Carolina University, where we have a center where we build solutions. Last year, LoRaWAN commissioned that marketing study, which showed that one good way to promote LoRaWAN and to develop solutions is to pair communities with academia that together can create interesting solutions for problems that they face. So on our end, what we are doing is we have a market that is underserved. Eastern North Carolina, I'll give you a little bit of a background, a lot of farming, but not necessarily very affluent region. Nevertheless, quite a lot of problems. And frankly, myself, I did not realize how many problems are out there, how simple some of these problems are. But the biggest challenge is that there is no idea, there's not even a concept of what's possible with technology for some of these communities. We cover everything in that region. We built a platform to make it easy to deploy sensors for these communities. Our goal was to reduce this barrier of entry to technology, take away this challenge that people have or think they have when it comes to actually using technology. And once you do that, the ideas, the solutions are quite amazing. People come up with fantastic ideas. So we built this platform called Python. It's all LoRaWAN based. Right now we cover about 1,000 square miles in Eastern North Carolina, and we constantly build solutions with the communities that we are engaged in. And I'm running the Center for IoT Engineering and Innovation, where we actually build these solutions. So we have the technology expertise, we have the infrastructure to do the testing and validation and so on. We involve students, we involve subject matter experts in specific domains in smart agriculture. So I'll give you 3 very simple stories, very simple examples. And this is not rocket science. This is not something tremendously complicated. Yet, in the life of farmers, it makes a huge difference. And so really, in the end, the challenge before us is how do we get this type of capability to as broad of an audience as possible? So here's a very, very simple example. We actually engaged with this farmer through a research project. So this is sort of an issue that came up through conversation. He has a bunch of grain silos. He needs to go up and down to check on those and see what the level is for his grains. We actually installed the LoRaWAN gateway for a different project, for a research project, on the top right corner, which is the grain elevator. And now that we have the footprint, we said, OK, so let's try to solve this problem for you. So we put a distance sensor on top of that trap door on the top of the grain elevator. So now he has not only real-time information about the grain level in his bin, but more importantly, he has a history of how that consumption goes. And so once you have the data, obviously data is cheap, insights are interesting. Now you can extract the insights from the data, and now you can actually do planning. You can use intelligent analysis to figure out other things. Same farmer. So as I said, once the footprint is there, once the coverage is there, solutions keep coming. Needs keep bubbling up. In eastern North Carolina, we have a lot of water, too much water. So the farmers need to drain the fields, needs to drain this water from their fields. So what they have is they have these irrigation canals, and the way it works is the farmer early in the day is going to go by the canal, see what the water level is, turn on a pump, go on with his daily duties, and whenever he remembers, he's going to go back, turn off the pump, and again, finish his day. Obviously inefficient. Let's not talk about gas emissions and all these other things, which are obviously not helpful, but not efficient for his daily life. So very simple. Again, surface water level surface water level sensor installed. He has this in real time. He can now make decisions. Again, data, insights. But also now we are helping him activate the pump control. So obviously workflow automation. So now data, insights, automation, and now we solve the problem. This is useful across this entire region. These folks didn't even think that this is possible. And then the last one that I'm going to talk to you briefly before I hand it over to my colleagues, Eastern North Carolina, catfish farms. The biggest problem that these guys have is when it's getting really hot, the dissolved oxygen level in the water is dropping significantly, which can kill the fish. Now, what they do today is they hire people who have to measure manually the dissolved oxygen level during the day and during the night. And the problem is not just that it's expensive. The workforce is not reliable. I was talking with some old hands on the farm, and they were telling me, we cannot wait for this to work and to be in place because people are just quitting on us in the middle of the night, and we are all scrambling to figure things out. Simple, dissolved oxygen sensor deployed in each pond, automated, automatically turning on aerators that oxygenate the water. And the ROI, if you calculate the ROI, is dramatic. They spend about $60,000 on just the staffing for this type of hand measurements, and a solution in LoRaWAN, it's in the range of $12,000, $20,000. One time, the installation. That they spend that on a regular basis. So, to sum up, I know we are talking about huge projects. I know we are talking about amazing smart cities. That's great. I think there's this huge community, this huge world out there where small problems can be inexpensively solved with LoRaWAN, with the right solution, and through engagement with the community. So now I'm going to hand it over to Chris.
Perfect. Thank you, Chip. So, IoT in dairy farming. I guess to get the obvious out of the way, dairy farming is the art of getting milk out of cows. And for those of you perhaps who haven't seen a farm, The interesting thing is that you often smell them before you see them. But they're interesting. Once you do see them, you get above them. There's much opportunity there to help people, right? And one of the best things you can do is just try and keep it simple. So here's a lovely image of a dairy farm in Ireland. Look around. What do you see? Cows? What comes out of cows? Silage. But the easiest thing to do, perhaps, and the best way to help people is just, as I said, keep it simple. Silos. Every farm has one. Farmers need them. Often what they're doing is storing feed in there. The cows are eating the feed and producing the milk. Problem is, how do you know what's in there? There's no holes. Maybe there's a sight glass. It's impossible. Often what you tend to see is this idea that we think we might have a ton or 2 tons in there. We don't really know. And perhaps we run out over the weekend. The knock-on impact of that means my cows don't eat, I don't generate revenue. That's an impact on real farmers. What they're actually doing, and I don't know if you can see this too well, but there are some indents here, and this was staring at us in the face for a long time. Like, guys, how do they measure what's in these silos? Well, what you see just here is a lovely wooden, a little bit of timber, and lots of indents. And what we found was farmers were punching in to the silo to find out what's in there. Can you imagine how inaccurate that is? So what we want to do is provide an end-to-end, very, very simple solution. And the reason it had to be simple, we go back to a study in the UK. 5% of farmers have adopted digitalization, roughly. It's one study, okay? What's the reason? Well, one of the primary contributing factors to that was that there are too many solutions to the market. Who do we trust? What happens if I need something else? Software, subscription as a service runs away, and quite quickly the cure becomes worse than disease. I'm spending more than I'm gaining. So we had this idea, empowered by the LoRa Alliance, that with the partners here in this room and in the industry, that we can deliver an end-to-end solution that helps real farmers, right? So what we're essentially looking for are micro deformations on the silo leg. We install them, and we're looking for compression and tension. That's all very simple. We're transmitting that via LoRaWAN into a local gateway, into our network server from our good friends at LoRa, and then into a cloud server, and then most importantly, into the visualization layer where our farmers and cooperatives can get access to it. To give you an idea, in Germany there are around 50,000 dairy farms. In Ireland, 17,000. It's a lot. Majority of them are part of what we call cooperatives. They're signed up to buy feed, they buy the milk back. This is the real way if you want to help people quickly. Find the verticalization, find your niche and verticalize as quickly as possible. When we did that, we wanted to understand what was the impact, right? How do we really help these people? And there are 3 real things: the economic, the environmental, and the societal impact. And I won't read out all of these, but this was the impact map we drew based upon a LoRaWAN enabled sensor. Quite powerful, actually. Just to pick one out. Utilization of accurate feed tonnages, right? The misconception we have in the industry is that milk is bought based upon quantity. It's not. It's based on quality. Butter fats, protein, fat, and other fats. What you see essentially now is a dietary change, and people want high-protein milks, high-protein yogurts, high-protein cheeses. This is what's driving this change in farmers, right? And what we essentially see by allowing them to monitor what's in the silo is to accurately track essentially what each cow is eating. What's the protein content? And as a knock-on effect of that, we're actually helping farmers to get a better value for their product. They're still producing the same amount of milk, the same effort goes in, but it's better quality, more revenue for their farmer. We also see, obviously, of course, the demographic change in farming. I was on a farm a couple of weeks ago, and I had the pleasure of a man who was 76 years old. And I have no idea how he gets up in the morning, but he milks and herds 250 cows every day. And the reason he does that is because he has to do it. He has no one else. He's time poor, he doesn't know what to do, and his simple idea is that we're helping him. We're helping him do what he needs to do. Much to what Chip was saying, we're helping real people with very simple and real issues. Now, I won't read this, you'll be able to see it later on, but I want to look at specifically the return of investment, and specifically when we talk about cooperatives. So I was saying about this idea of verticalization and moving quickly as possible. Well, what we have is a sample case of 2,000 silos, right? And what we know, there's a value contribution there, bottom line and top line for growth, of 9 million over 7 years. 9 million, right? Production, logistics, CO2 savings, and that's just economic impact. Forget about, well, not considering the effort and the helping out real farmers, as I said before. To give you an idea, this sensor here, palm your hand, right? 200 euros. It pays for itself 10 times over. Simple. Simple. Okay? Nothing more, nothing less. 9 million just based upon a simple sensor. And that's me.
Okay, so in this field, you can see some soil moisture sensors. I think in the bottom right here, you can actually see the top of a soil probe that will go down about 60, 80 centimeters into the soil, measuring the temperature, measuring the soil moisture levels in the soil. And then you can see above that some technology that's sending the data from that soil moisture sensor up to a satellite. And that's what we do at Wyld Networks, is do the connectivity piece for connecting sensors directly to satellites, particularly in those areas that are outside of range. And roughly 85% of the surface of the Earth doesn't have any cellular connectivity. And that's a lot of land, and of course a lot of that land is agriculture, so obviously the seas as well. And how do you get data from those worlds that are outside where it's reasonably practical to set up a local area network? And that's where satellite connectivity can come in, and that's obviously particularly useful for satellite. And we think there's a massive opportunity for that, to build IoT data, to meet that demand for IoT data in many factors, in many different ways, as we've been discussing already. But primarily you're looking at boosting profitability, boosting yield in agriculture, reducing valuable inputs like water, like the pesticides and things like that we don't really want to be using if we don't have to, monitoring it to make sure that we can do that, and of course meeting sustainability goals as well. So here's a diagram that's sort of outlining the rough structure of sensor to satellite setup. So you've got your sensors, you've got either an embedded solution, so embedded modules with antenna and power control inside the sensor, so the sensor becomes autonomous, can be put anywhere, so it doesn't have to think about gateways if it doesn't need to. If you're in range of a gateway, obviously it's going to make sense to go through a gateway. Data's going to be cheaper going through a gateway than it is going through a satellite. But in those instances where either you're moving your sensor outside of the range of a gateway, or you're simply out in the middle of nowhere where there are no gateways available, or it would be impractical to set up there because you have no power, and because of the cost of running it, and because of the practical nature of running it, then you've liberated yourself. So it's a liberating feature in a way for sensor manufacturers in those environments where it's difficult to reach in distant locations, etc. Obviously, you're taking data up to the satellite. You need to bring it down. It comes to a ground station. It comes into a network management tool. We have a tool called Wyld Fusion that does that. You can see maps of the satellites, where they're going. In our case, we have We're sort of satellite partner autonomous, so we work with a number of different satellite companies, but LoRaWAN is a key part of that, and we work closely with our good friends at Lacuna Space who are here today. You've probably seen, hopefully you've seen their satellite on their stand upstairs. And then we send the data, because we're not specialists in every type of thing that's being sensed, we're going to send the data to the end application through an API. So here's an example of something that we've done, and this one is in Namibia. And we're monitoring soil moisture in a date plantation, and this plantation is really, really remotely located. Water is at a premium in this location, but is critical, and the timing of the application of water and the understanding of water in the root system, so water at depth, not just what you see on the surface, but what's actually happening at the critical points lower down in the soil, is really, really important for the farmers who are working this land. You can't really get that data from a looking down satellite. You've really got to have the ground truth. You've got to have what are the factors, what are the actual readings below the surface of the soil to get the data that you need to make the right decisions around how you can monitor the use of water to get the best yield, to reduce the amount of water, because water is an expensive product these days, and to operate sustainably as well. And just to give you an idea of what that looks like sort of actually in the farm there, you can see a soil moisture sensor at the bottom, satellite transmission at the top of that pole. And that's the sort of scale there of the sort of farms and the plantations that we're working with. They're very big, in the middle of nowhere, no other form of connectivity, no real easy access to power. And that's where satellite technology can come in. Now, it's not just for soil moisture, obviously. There are many, many applications for this, from livestock tracking, tank monitoring, and lots of other things besides. But that's hopefully gives you a rough idea of what you can do with satellite IoT in agriculture. Thanks.
Thank you, everyone, for staying here. Well, I will go through my presentation, and my presentation will be focused on a major problem in Africa, which is the scarcity of water and the quality of water. So first of all, I will just introduce our strategy within 3S Group. So first of all, we are a system integrator, and we are deploying a nationwide IoT network based on LoRaWAN technology. We started working with LoRaWAN products since 2016, so it's quite a long journey, and we have reached a kind of maturity within our products, within our way of thinking and deploying the products. We also work closely with universities, with R&D centers, because we think that these are the major fuel in order to have state-of-the-art quality products that can be delivered on time and with quality and with efficiency. So the challenges, they are not similar to the ones that we can see in Ireland or whatever. And as you can see, the farm that you showed in Ireland or the farm which is in Namibia, it doesn't reflect the reality everywhere. In Africa, the distribution of water resources is very odd. It's not even. You have the largest desert in the world, and this desert is growing. We have desertification, we have too many problems, and on top of that, you have the global warming, etc. So the water is the water scarcity is a huge problem for farmers in Africa. And as you can see also, we have also a problem of demographics. So the most of the demographic growth from now to 2000 and 2100, it mostly will come from African population, and this population needs to be fed. We have also some problems inherent to the continent in itself. It's policies, government policies, the literacy of farmers, the financing, etc. So we come up, 4 years ago, we come up with a new product, which we called X3, and X3 was mainly developed by universities, and we introduced a layer of artificial intelligence. It was a joint work with major R&D centers in Tunisia in order to address some key crops, like trees, like wheat, like many vegetables. So we introduced some models who can help the farmer adopt the right irrigation policy when it comes to first the scarcity of the water and then the quality of the water. And within 2025, next year, we hope that we can achieve another major milestone is how to build cost-effective salinity sensors built with nanotechnologies locally, and how to monitor NPK in the soil. NPK is nitrogen, phosphorus, and potassium. And those three elements are major factors for the behavior of the crops. We also adapted the products in order to be adapted to the literacy levels of the farmers. 80% of the farmers are not literate in Africa, so they cannot read very well. Most of the time, we need to adapt, the iconography, the buttons, in order to be easy to use, and to be also efficient. So, I've come up. I think I've been on time, so we can go with questions.
Perfect. Thank you so much. All right, so thank you everyone for the presentations. They were very insightful. I thought the value of the folks that are involved in the panel comes from the varied scale of projects, everything from national scale to large remote farms to small farms. So I wanted to sort of dive a little bit into each one of those ecosystems. So I wanted to start with you, Anas. You were mentioning a national infrastructure. How do you get to where you can drive a national infrastructure for a LoRaWAN access?
Well, actually, to be honest with you, deploying a network, a nationwide network, is a loss of money. You cannot get anything from deploying only the network connectivity. So this is why we are working with universities in order to build those use cases who will bring value to this network. Because otherwise, we will not succeed. We will not get any ROI. And I'm not talking only about agriculture. This is one of the examples. But we also deploy solutions in smart cities, in industry, in logistics, etc. And this is how we are getting the value. First of all, in order to get the ROI from deploying the network, which is quite expensive. And second, it will drive the market towards adoption of LoRaWAN technology.
Interesting. And who's funding? Who's funding the operation of such an infrastructure?
Our company, ourselves.
I see. With support from the government or just?
No. It's private funding.
Private funding.
And we are working with a national telco, with a legacy telco in Tunisia, in order to get the infrastructure, to have the towers, in order to build to install the gateways.
Understood. That's very interesting. So I'm interested now at the next level up in terms of scale, large farms. In this case, how do you make the business case for these farms? Because these farms obviously are going to operate at a different level than the small projects, small farmers that we are talking about. So how do you make the business case for using such an infrastructure for them?
Well, I think it depends where you are in the world. And a good country to give as an example is Brazil. So in Brazil, you'll have small-scale things that are still outside of areas of connectivity. So, for example, we're working with a strawberry grower in Brazil whose glass houses are just remotely located. It's very difficult for them to get data, so they'll have lots of sensors every 6 feet in their beds for the strawberries. And they'll have a gateway, or they'll go direct to satellite, or they'll go from the gateway to satellite. In the wider expanse, where you've got either livestock or you've got big crop farming, it's a different story. And an example might be we're working with a citrus farm in Brazil that has 10,000 hectares. So it's absolutely huge, and they're only looking to reduce the water input by 2% without losing any yield. Now, water's a key thing in citrus farming, and you know, you've got to apply it at the right time. You've got to make sure to get the highest sort of, you know, crop value, the highest yield value, but also you don't want to use more than you have to. So even by reducing by 2%, where there are sometimes, you know, legal restrictions on the amount of water you can use, and there's a definite issue with water and water supply, it's very important for them to go down. But even going down by that much on a big farm like that, it makes a big impact.
So just to tie in a little bit on what Anas was saying, making the case, right, making use cases on top of the infrastructure. He's mentioning working with academia, working with universities, finding subject matter expertise there. What about Wyld? How do you build the science behind the technology?
So we're working with a number of partners in this respect. So in Brazil, we work with Embrapa, which is the big government agricultural technology kind of organization, very influential in Brazil. CREA is a similar organization in Argentina. In the UK, we work with Innovate UK, which is a funding body, and they fund a number of agricultural projects, including one we're doing with a company called AgriSound, who have a wonderful sensor that listens to the sound of pollinators. So it listens to bees, it identifies the species of bee, and it counts the number of that species. So this is very, very useful if you're an almond farmer in California and you have a 2-week period of pollination. If you don't meet that need of the flowers, you are going to lose significant yield on your crop. So, you know, almond farmers in California will ship in hives from Florida on the truckload in order to meet this need. So understanding the data and understanding what's happening and what isn't happening at an early stage in the season enables you to sort of, you know, to do that better.
Very interesting. So
clearly, partners, in answer to your question, it's Innovate UK. It's educational.
It's an ecosystem.
It's an ecosystem. Yeah.
So Chris, smaller scale, small farmers, they still have problems. They can still benefit. Actually, I have 2 questions for you. One, sort of in the same vein, how do we make the case for small farmers for these solutions? Then I'll have a second question after that.
Yeah, sure, no problems. I think with regards to a business case, whilst they might be small, they're still inherently subject to the same issues, right? And often it seems, particularly in agriculture, that they are forgotten about, perhaps, when regulations are made. And we have to pay particular attention to that when we're looking at, and I'll give you an example, the No Nitrates Directive, for example, and each EU member state having to monitor the nitrate runoff into water. This is a big knock-on impact for farmers. So as opposed to us making the business case, I think regulatory pressure does it for us anyway. And particularly then tie it in with demographic change, it's a simple case of having to adopt new technologies, simply. From our perspective, though, as I said before, is we have to be fast. We have to, this element of verticalization, the case in many ways for us is to approach cooperatives or feed companies who perhaps could provide a grant or a levy, or they assume the risk because they might themselves benefit greater. And that takes that financial burden away from the farmer who, again, might only turn over 300,000–400,000 euros. And the margin is so paper thin they can't invest in new technologies. So it's a real hybrid model for us, real hybrid model.
My second question would be, this is from our experience. Mm-hmm. I'm curious if you have the same experience, maybe Anas, you have the same experience. I think in your case, Eric, farmers already know exactly what they're doing, so it's different. But so one of the farmers that we talked to, they were so excited about this whole technology involvement and so on, because what he was saying was, I can show this to my son who's studying in the university, and now maybe I get him excited to come back and work on the farm. Do you see the same? Do you see the same type of sort of possibility?
I answer this question with a smile on my face because I've been present for all installations that we've done in the field, and regardless of age, you see this interest from everyone. You know, what are you doing? How does it work? Please tell me. It's my data at the end of the day. But in particular, you're right, for the younger guys, the second generation or third generation farmers who perhaps in some instances transferring to soft industries. Ireland's a really good example of this. 60% of the land is dedicated to agriculture, but around Dublin, it's a huge soft industry. SAP, Microsoft are all there. And you can certainly see this level of engagement and new technology that could bring back younger generations to the farm. You could. Particularly with an open ecosystem, what else might we be able to do together? Single applications here and there, such as silos, interesting, not groundbreaking, but together, collectively, like in the Alliance, I think you're right. I think that could happen.
One of the most challenging aspects of presenting, or let's say dealing with the technology in Africa, is mostly how to get the fundings, how the farmer can get the money, either from loans, from banks, from public grants, or whatever. So before talking about technology, it's mostly how we can get the funding and how we build the business case and how we get the ROI. I think this is the most compelling factor in order to deploy the solution. Afterwards, when the solution succeeds at farmer X, there's no reason that you don't have the same success at farmer Y. There's another challenge, is the size of the farms, of the land. We are not talking about thousands of hectares. We are talking about maybe some hectares or some tens of hectares. So the parcels are very small. And investing will be, when you calculate the investment to the surface, definitely the investment is quite high.
Yeah, I think, I look at the market in terms of sort of three sectors. You've got sensor manufacturers, and then you've got the big players in the middle who want to get things done, who've got problems they want to solve. And then you've got the sort of data platforms at the other end, if you like. And that, the sensor manufacturer and the platform might be the same person, but might not. There's no one kind of platform that is an Amazon of agriculture yet. No one's quite got to that point. There's some great players. Obviously, the big people like Bayer have Climate View. You've got John Deere's stuff, which is focused around their machinery. You've got Raven, which is a fantastic platform that everybody says is wonderful. But no one's really dominated the market there. So it's a complex ecosystem. But in the middle of that are these companies that want to solve big problems, mostly agriculture, sometimes environmental, or a combination of those two things. And the farmers are sort of downstream from that to a certain degree. But it's really important to talk to them because they're the ones who are really right at the coalface.
Yeah. The conversation sparked two questions for me. I know we have only 2 minutes, but one question would be, do you find, Anas, that you need to help farmers learn how to apply for funding?
Well, there are some mechanisms. Every country has its own mechanisms. There are also mechanisms coming from USAID, from European Union. For example, when it comes to our research with universities, we use a program from European Union called Horizon 2020, which is a global R&D program funded by the European Union, and it enables universities from the South Mediterranean universities in order to be part of global research groups. And this helps us get the solution, get efficient solutions ready.
And then one last question for the three of you. In my experience, when you start to go into farming, depends on the size, depends on the scale, but regulations come into play. I would be curious to know what your thoughts are about how do we deal with regulations. It's nice to have beautiful technical solutions, but if we hit that wall, then we kind of slow down really fast.
I would just say sometimes the regulations work in our favor rather than against us. I mean, if you look at, say, the Murray Basin in Australia, where the Australian government has had to put strict regulations on usage of water by agriculture because they're draining the basin basically, and it's causing other problems for industry and other things. But in fact, that's an opportunity for us in the LoRaWAN community. Yeah.
Justifies.
Yeah, yeah.
I can only echo that. I mean, whilst it could be challenging, it certainly poses its opportunity for us, and often for the better in many ways. It needs tweaking in some cases, but the direction of travel is a positive one in many scenarios, in my opinion.
To be honest with you, the problem of, let's say, global policies, it doesn't impact the agricultural process in itself. But what we see in most of the African countries, and even we have the example in Italy, which had a lot of delay in implementing a regulation for LoRaWAN networks. I think they got the regulation in 2023, I think. So we have the same problem in some African countries where the regulators are not in compliance with the ITU ISM bands. So this is, I think, in my opinion, this is the only obstacle in order to get the projects on a large scale.
Well, we are out of time. Thank you very much for the discussion. Really appreciate it. And thank you, the audience, for staying all the way to the end of the conference for our session.